Hello everybody, welcome back to another edition of the EcoStruxure Machine Expert HVAC. I'm your host, Leandro Mada, and in this video what we're going to see is how we can scale a variable in our software. So let's go to the presentation. So what I saw, for example, in other software is that we have a specific function called lean_trafo or scaling in other software that basically we have analog value, and then we have the function block, and then we got on the output and scale variable between some ranges. So basically what it does is to create the equation of first grade, so we can linearize the variable. So this is how it works. Okay, the M172. So basically here counts the analog signal. Okay, and then on the BIOS parameter we have all these things, okay, in order to linearize or scale the value that we have. Now I usually don't change that and I leave it as a default, because depending on the type of analog input it also changes that. So I usually leave it as it is by default and then use an external function in order to scale what I want. But again, that is what I usually do. There is no need for you to do it. So as soon as we came from the analog input into the PLC, we received the analog signal, okay, in int format. Okay, what I usually do is to, okay, I have the signal, okay, I use a converter probably to change this to real, and then I use a function scaling in order to get the value already escalated. For example, if I know that this one is a 0 to 10 volt signal, I can specify here the raw value is 0 at 10 volts, but the maximum and the scaling, so the point from the for the first grade equation for linearize this is, for example, I know that 0 is, I don't know, in this case a pressure sensor is gonna be, I don't know, 0 bars, and then the other one's gonna be, I don't know, 5 bars. So the scaled signal is gonna be a real one from 0 to 5 bars. Okay, and then I can use this variable in my program. Okay, so basically that's the idea. So what I have done, because I saw that, or I wasn't able to find it in the software, is that I had created my own scaling function block that looks to something like this. Let me just move myself, something like this. So oops. So basically I have the enable of the function block, I have the analog input, but in real format. I have the minimum maximum for the raw value, and then the values that I want to scale it. And then I have the output in real format and integer format, and this one I didn't implement it yet, just give me an error when the inputs are not correct. So this is what I have done. So let's play a little bit around. Okay, so what I have done basically is to use this. It's just first grade equation from line from 2 points. So basically I have the raw value and then the escalated value. This is the calculation, you can see, very simple. And then this is what I do on the PLC. So I did this part and this part on the PLC, and then I calculate the output value. Okay, so let's go to the software. So this is the scaling, is on the library here, scaling, okay, ATA, converters, scaling. So I have, if I'm not wrong, the analog input right here. So this is going to be the input. In my case, as I didn't convert it, I'm going to add a conversion to real, so I can use it on my code. So let's connect to the controller. Okay, download. Yeah. So this is the temperature I have right now in the room. Let's open the watch and add this scaling. Scaling. Scaling here. So this is the input, the raw value in real, and then the minimum value and the max value. In this case, it's gonna make it easy. So it's gonna be 1000, and this is the temperature. So I know it's 21.8 in my case. So I need to put here the output is gonna be 100. So I know that I need to divide it by 10, basically. So if I enable this part, true, you can see that I have the output 21.8, okay, because it's a real value that I want. And this one, as it's an integer, the decimal part is already vanished. Okay, if you want to just have it as it is, as you have. Okay, so something similar, but without using this part. Okay, let's play a little bit more and see. For example, I have the analog signal that came from 0 to 10 volts, so it's gonna be 0 from 1000 if I'm not wrong, which is this. But I want the output to be, for example, the 0 volt indicates that it's gonna be, I don't know, 2 bars, okay, 2.0 bars, and then the output is gonna be 8 bars, okay, something similar like this. So you can see now if the output is 218, okay, 218, you can see that the output is going to be 3.3 bars. Okay, that's the idea, and this is how we expect this is going to work. So if we open the Excel just to double check that it's working fine. So when it's 0, this one's going to be 2, and when it's 1000, it's going to be 8. So if the calculation is right, I should be able to have this value over here when the input, it has this. But in my case, I already specified 218. So 218, I put it in here, 258, 218. Okay, 3.3, which is what I have here. Okay, so this is working. So this is the scaling functionality that we can do. You can do it manually or create your own function block. I have already created this function block and then add it into my own library. You can use it from here if you want. So basically that is the idea for the scaling. Create this part, use the function block and check the link. Okay, so the other thing that I want to show you is that if you go to let's disconnect, go to commissioning, you can see that you have the calibration. Okay, you can see they have the gain for different type of analog inputs and different offsets. There is a different kind of calibration, so you can play with this if you want, but I don't know why. Probably I'm used to play with other PLCs and I do this outside. For example, I make that small calibration on the it's called in the configuration of the hardware. So for example, the raw value, we know that it can be from this to this, but probably I can scale the function to go from 0 to 1000, or that it gives me the value. So that is another option. Okay, one good thing is that this variable has already an address, so you can do it externally and change that. In other PLCs, for example the M251 or the M221, you don't have this possibility to access to the calibration. You just need to be offline change it and then download. So that's why I'm used to do it in the other way, to have it as a default and then have another variables in order to change it. That's the main difference. But as you saw here, we can add a different function block. We can use those variables for each of the analog inputs, or we can easily create our own variable, just define the analog type, put it on the block, make the calculations, and then have the result that we want. So this is for the scaling of the variables. It can be used for analog imports or outputs in order to conditionate the output. So this is it for the scaling. Thank you very much for watching this video, and I see you on the next one.